Welcome to Sealtron's safety training on crane operation, rigging, and hoist safety. This training will cover basics of cranes and hoists, inspection requirements, rigging basics, safe operation, and employee training. Crane versus hoist, what's the difference? First things first, a hoist helps to do one thing: move heavy loads up and down. An elevator is probably the most well-known hoist. Elevators are the perfect machine for transporting loads vertically, but in no other direction, unlike a crane's functionality. On the other hand, a crane can move in 2 or 3 dimensions. Overhead cranes suspend from a beam or move along a rail. Just like cement is a component of concrete, a hoist is a central part of an overhead crane. Essentially, the crane moves the hoist around. Sealtron has both jib cranes and overhead monorail cranes. The 2 jib cranes are located outside the machine shop and inside the receiving dock. The 2 overhead cranes are in the satellite plating room and in the northwest corner of the building by the old tool room. Please take a moment to look at some of the different terminology for parts of a crane. You may pause the video if you need more time with this slide. Now please look at the parts of a jib crane. Again, you may pause the video if you need more time with this slide. You are completing this training because some aspect of your job requires you to operate a crane in some capacity. As a crane operator, you are responsible for inspecting the crane at basic maintenance, or at least informing the maintenance team of any needs. You are also responsible for following all safety procedures, maintaining focus during operations, and reporting any issues that arise. This next section will cover required crane inspections. Inspections are classified as either frequent or periodic. Frequent inspections are completed each day before operating a crane and at least monthly. Periodic inspections are completed annually by a certified third-party inspector. Inspections cover not only the crane, but also any rigging and slings used, the load, and travel path. Here is an example of what items are inspected during a frequent inspection. We will cover each of these items in the upcoming slides. If a fault is found during an inspection or while operating the crane, the following steps must be taken. Immediately stop using the crane. If safe to do so, lower the load to the ground. Tag the crane or sling out of service, and then report the issue so that it may be repaired or replaced. Every day before use, check for the appropriate signage on the crane. Each crane and hoist should be labeled with the capacity that the equipment is rated for. This signage should be visible from the floor. Begin by making sure the crane is not tagged out of service. Ensure that the load block is in proper working order. This is the part of the hoist that connects to the load or sling. It should move freely and be free of kinks, nicks, cuts, and other signs of wear. Check the sheaves or pulley block if the crane has one. The parts should all move easily. Make sure any protective covers or guards are in place if the crane has them. Next, we will inspect the hooks on the crane. The hooks should not be bent, twisted, or stretched. Check for excessive wear, corrosion, nicks, or cuts. All hooks must have a safety latch that is in place and functional. If the hook has any bolts or pins, those must also be in place and functional. The hook should smoothly rotate without any hang-ups or noise. Slings are the pieces of equipment used to attach a load to the crane hook when a dedicated attachment point on the load is not available. Slings need to be inspected prior to each use. Sealtron only uses chain slings and synthetic web slings, but we will cover all the sling types in this training. Chain slings should be inspected for bent, twisted, or stretched links, excessive wear on the inside, heat damage, and nicks or gouges. Be sure to inspect the entire length of chain. Look for the proverbial weak link in the chain. Wire rope slings should be checked for cracking and pitting, excessive wear and kinking, deformation, corrosion or rust, heat stress, broken wires, and damaged fittings. Begin inspecting fiber rope slings by examining the surface. Look for dry, brittle, scorched, or discolored fibers. Then move on to the interior of the rope. It should be clean. The presence of powder or dust on the inside of the fibers could be the result of excessive internal wear. Finally, scratch the fibers with a fingernail. If the fibers come apart easily, there has likely been chemical damage and the sling must be discarded. Synthetic web slings should be checked for acid or caustic burns, holes, wear, cuts, tears, and snags, broken or worn stitches, excessive abrasion, embedded particles, and knots. If at any point the core fibers of the sling are exposed, then the sling needs replaced. Heat damage can also cause the webbing to harden and stiffen, and the sling will often show signs of melting, bubbling, or charring. Rigging hardware such as shackles, links, wire rope clips, and end fittings must also be inspected thoroughly and treated with care. Retire hardware if signs of wear or deformation such as cracks, nicks, or gouges are found. Remove the equipment from service if excessive wear of more than 5% is detected in the throat or eye of a shackle or more than 10% wear is found in other areas. Malfunctioning, missing, or improperly installed hardware is also grounds for removal from service. Check latches, swivels, bearings, locking devices, and the installation of wire rope clips and wedge sockets. It's also essential to retire hardware that has been altered on the job, such as by cutting or welding. The last of the frequent or daily inspections covers operational checks. Test the functions of all the buttons. Check for smooth operation and functioning brakes and stops. Listen for abnormal sounds. Operator experience comes into play here. A more experienced operator knows what sounds are abnormal and require further inspection. Now we will discuss periodic inspections. These inspections are completed annually by a certified third-party inspector. Although operators will not be performing these inspections, it is best for them to understand what is inspected so they know what to look out for during normal operations. The inspector will check connection points for loose or broken bolts and rivets. They will also check for cracked or insufficient welds. Damaged sheaves and drum prevent free movement of the hoist when moving suspended loads. When inspecting sheaves and drum, make sure to check for worn grooves, worn groove lands, sharp edges, and cracks. Brake system parts include linings, pawls, and ratchets. Pawls connect the ratchets to the rest of the brake system. Failure in the brake system means the load is uncontrollable, allowing it to potentially crash into another object or even employees. When inspecting brakes, they will check for excessive wear and proper adjustment on brake system parts, linings, pawls, and ratchets. The inspector will also check for proper functioning of electric control brake. The inspector will check electrical components for load, wind, and other indicators over their full range and recalibrate as required. Inspectors will check covers and guards, making sure that all covers or guards are in place, secure, and undamaged. Damaged or missing guards need to be replaced or repaired immediately. During the inspection, the inspectors will check all bumpers and end stops for damage. They will check for proper restraints and obvious undersizing or improper energy absorption capabilities. When inspecting the trolley and runway rail, they will check rails and fastening devices for looseness, gaps, misalignment, and wear. When inspecting the trolley and runway rail, inspectors check rails and fastening devices for looseness, gaps, misalignment, and wear. Now that we have finished talking about inspections, let's talk about some rigging basics such as hardware selection and hitch types. You begin choosing the correct rigging hardware by using the rated capacity. At most workplaces, slings are commonly used in rigging. A sling that has been well selected and is properly functioning will keep the load stable and secure throughout the course of the lift. However, using the wrong sling may lead to a load that sways, slips out of the sling, or causes the sling to snap or otherwise fail under stress. While a sling's rated capacity is essential in choosing the correct sling, other factors are also important, including the material composition of the sling, its size, design, and configuration, its condition, and each sling should have a tag that states the rated capacity, the date it was put into service, and its length. A sling's rated capacity is not always the simplest thing to take into consideration. It is also very important to consider the sling load angle and number of legs. A sling with a single leg, hooked at a 90-degree angle to the load, can lift the maximum amount that the sling is rated for. Multiple legs can be used to reduce the weight on each individual leg, but the total weight on each sling must be less than the rated capacity of the sling. When the leg is less than 90 degrees, additional stress and weight is applied to the sling, reducing the rated capacity. For example, a sling at 30 degrees has only half the rated lifting capacity as a sling at 90 degrees. Each sling type has pros and cons. Be sure to choose the right type of sling based on the load and job requirements. Consult the JSA for each job task if you have questions. Chain slings are strong and durable, but damaged links often go unnoticed. Wire rope slings are also strong and durable but can be hard to fit and can experience cracking or kinking. Fiber ropes are lightweight and easy work with but can only lift light loads and are easily damaged. Synthetic web slings are very durable and comparatively strong but are susceptible to damage from heat and chemicals. Part of the art of the rigger's work is to employ the proper hitch for a lift. Many types of hitches may be used, depending on factors such as the weight and shape of the load and the sling or slings being used. A few hitches commonly used are the single vertical hitch, where a single sling is used for a vertical lift. The bridle hitch, in which two or more slings meet at the crane hook. The basket hitch, in which a sling wraps around the load or a part of the load to support it. And the choker hitch, where the hitch tightens around the load as it is lifted. If you are unsure about which type of hitch is best for a particular lift, talk to the people who know, such as your supervisor, the crane operator, or a more experienced rigger. Never twist a chain or sling to adjust its length, this will compromise its load-bearing capacity. You'll learn much more about how to hitch particular loads and when to use certain hitches as you gain experience. Now let's discuss safe operation of cranes. As you get ready to prepare a load for a lift, protect yourself by donning all required PPE. This may include a hard hat, safety shoes, and work gloves. Before lifting the load, make sure the hook and hoist line are directly over the load. If they are not, the load will move or swing, potentially causing an injury to someone or damaging facilities or equipment. Also, check to be sure that the hoist chain or line and the slings are not kinked or twisted around each other. This could cause the load to twist, rotate, or flip once it is lifted. Be sure to check that the path is clear before you begin moving the load and never lift a load over a person. Never leave a suspended load unattended. Here are some more tips on safely operating a crane. Never pick up loads at an angle. If you need to, move the load on the ground using other means before using the crane. Don't overload the crane. Break a larger load into smaller loads if needed. Never rush. Lift and move the load slowly. Don't jerk the load as it may shift. Pay attention to what you are doing. Never lift loads over people and never allow anyone to ride the crane. If you as the crane operator cannot see where the load is moving for any reason, be sure to get help. Here are some common hand signals used to communicate when verbal communication is not an option. Be sure to discuss with your helper beforehand to prevent any confusion. Even when you know that your equipment is suitable for the weight of the load, there are still some serious questions you need to consider. Will the angle of the sling take away any of its capacity? Have you rigged the load to the center of gravity of the crane and lift line? Are there any sharp surfaces or corners in the rigging that could cause a sling to tear? Should padding be used to protect the sling? Will the load be under control along the entire path of the lift? Should a tag line be used to guide the load? Are there any obstructions along the lift path that must be cleared? Can they be moved out of the way? Will the suspended load be clear of all personnel? Do unusual environmental conditions such as high winds, rain, or heat need to be considered? As you can see, there are many factors to keep in mind. That's why it is smart to discuss each job with everyone involved and make doubly sure you are making the right decisions. Now get with your trainer or supervisor and demonstrate what you have learned by practicing safe crane operations.